Okay, good morning, everyone. Welcome to our subject, financial modeling. So this subject is all about using software tools, using in particularly predominantly Excel. We're going to use Excel in order to solve finance problems. As I mentioned a while ago, we'll start with the basic one, the time value of money. We'll discuss amortization. We'll discuss topics like capital budgeting, topics like valuation, and the weighted average cost of capital, weighted marginal cost of capital, plus others. And we'll take a look at advanced topics. We're going to make use of an additional topic will be business analytics, making use of Excel. Towards the end, we'll also make use of, I'm thinking of using Python in this class, okay? So that we can have some learning about how we can make use of very powerful softwares like Python in order to do financial modeling. Okay, now I'd like you to uh, maybe put in the chat box class on a scale of 1 to 10, 10 being the highest and one being I don't think anyone will answer one. How will you rate yourself as regards your proficiency in the use of Microsoft Excel? Could you please honestly, let's say 10, uh, you're very much knowledgeable about Excel. You know Visual Basic for applications, and maybe 9, 8 would be Excel, that you're very comfortable with it, or 5 would be just middle. There are many functions that you don't know yet. Okay, so how would you rate yourself, please? Thank you. Thank you. Alessandra, Nix, Jashan, okay, Johan, thank you. Aliana, thank you. All right, thank you so much. So I was expecting that you'll be in the upper range of of uh, uh, in this, how do I call it, in the rating, okay? And yeah, based on what you told me, what you wrote there, okay? So we'll start first with the basic, okay? Basic use of Microsoft Excel as far as the concept of time value of money is concerned. Now, once again, I'd like to ask you, who among you are familiar with the FV function, PV function? Okay, these functions FV, PV, rate, PMT, NPER, okay? Examples of functions that make use of the time value of money. Have you used these functions before in Excel? Kindly, once again, chat, please, yes or no, so that I know how to pace myself. Yes, if you have used these functions before, FVPV rate. Okay, thank you. Thank you. Thank you, Nix. Thank you, Jashan. Okay, good, good, good. So that means that this is something uh, that will not be a review for you, but this is something new for you to learn. All right, so let's begin. We have several worksheets here. We'll most probably will use this for the next two, at most 3 sessions, because these are quite many. Okay, if you look at this, okay, there are many lessons here. This actually is almost the whole part of fin management, your subject, uh, FINA management or fin management, and we'll just discuss that in 2 or 3 sessions, and then move on to more advanced topics. So this subject is really interesting, and hopefully by the end of this course, you'll be able to really say that you have a good grasp of Microsoft Excel and its application in finance. Okay, so let's start first. This one I'm sure will not be you already are already familiar with. Okay, we know that we know of the concept of the time value of money. we say that 1 peso or $1 today is not the same as $1 after 1 year. If you were given an option to what would you want, $1 million today or $1 million after 1 year? I'm sure your answer will be you'd like to have $1 million today. Okay, because you can put that in an investment, you can put that in an instrument that earns interest. Then after 1 year, you have more than $1 million or 1 million pesos for that matter. So I'm sure you know that the formula to compute for the future value, okay, is the present value times a certain rate. That's 1 plus r raised to the t. Okay, the process of getting the future value is called compounding. Okay, I apologize for. Okay, I lost my digital pen, so I can't use my digital pad. So I'm just using my mouse, so it's quite difficult to do this. So for example, if you were to put let's put money now, okay, at time zero, 1, 2, 3, 4. So I'm discussing the concept of the time value of money. Okay. If I put $100 or 100 pesos in a certain instrument, okay, and if I want to know how much will that be after 4 years here, after 4 years. So that is the question that's being answered by this formula. Okay. What is the future value, okay, of a certain amount, let's say a lump sum amount of 100 placed today? Time zero here means today in 4 years' time. For example, that's the problem. So how do you solve for that question or for that problem? Very easy. We just use the formula that the future value is equal to the amount, which is present value, times a compound factor. This one. R stands for the rate. Okay, the rate, the growth rate, the interest rate, and T stands for the number of periods. So T here will be, the number of periods will be compound period 1, compound period 2, compound period 3, and compound period 4. So there will be 4 compoundings. So the formula is PV times 1 plus R raised to the T. Okay, so let's start with an example. Okay, let's take a look at the details here. Okay, suppose you have 1 million pesos. And we put it in an instrument, in an investment that earns 12%. Okay, 12%. Now, how much will be our investment in 20 years' time? Okay, how much will be our investment in 20 years' time? Okay, as an exercise, I'd like you to put here, use this, formula, okay? Use this, and then write your equation here. And then I'd like you to put in the chat box, uh, send it to me directly. Do not send it to everybody because I'd like to see the answer, your answer here. For example, you put here is equal to, right? So what will be your PV? It's equal to this one, right? So click that. Okay, so once you have written the complete formula, you copy the formula and send it to me directly so that we can compare notes. All right, I'll give you a minute to do that. Okay, so do that please now. Okay, thank you, Alessandra. Yeah, that's correct. Yeah, but Alessandra, please use the cell references. Okay, thank you, Nix. Do not type the values. Okay, good. Thank you. How about the others? Okay, good. Yeah. Johan and Jashan, please write the formula, not the amount. I want to see your formula. So let's wait for Jashan and Johan. Okay. Yeah, but Jashan, I want you to write, and Johan. Okay, I'm sorry. I think my instructions are not that clear. So let's do that first. Okay. All right. What I wanted was for you to compute for the future value. And the future value is equal to, this is the formula, the present value, which is this one. Okay. So I was expecting you to give to me this answer, B9, and then times. Okay. So you'll have to use the asterisk here, times this compound factor. So parenthesis, 1 plus our R is this one, right? And then raised to the T. In Excel, raising to exponent is shift 6 there. Shift 6 times this one. So this should be the answer that you should have given me. Okay? So the amount, the future value of a lump sum of 1 million today after 20 years, get having an interest rate of 12% will be, control enter. Okay, it's 9.646,000. Okay, now around 9.6 million. I'm sorry. All right. So any questions about this? Oh, I'll give you a few seconds to make sure that you have this. And it's one, and once you have that formula in your spreadsheet, in your Excel worksheet, please chat yes before I continue. Okay, good. Thank you. Okay. It's not yet done. Johan, how about you? All right, good. Thank you. Okay, so this is what's good with a small class because I can really oversight your progress. All right, so this is the formula class. So this is the manual formula. Okay, you link it to the present value, multiply it by 1 plus the rate raised to the period. Now, in Excel, there's a formula called FV. FV. Okay, so if you type a formula, a function in Excel, okay, before and do not type the parentheses yet, Excel will give you the meaning of this formula, what this formula is all about. So it says here that the FV function returns the future value of an investment based on a periodic constant payments and a constant interest rate. Okay, so you can compute for the future value of an investment either as a lump sum or just one amount, or periodic constant payments and a constant interest rate. So it assumes that the interest rate will be constant throughout the period. Okay, and if we type the open parentheses, you'll notice that there are 4 parameters that are required: the rate, the NPER, PMT, and you notice something here, PV and type. What do you notice about PV? Okay, what do you notice about PV and type? You may unmute yourself. Yes, thank you. Yeah, that's correct. Thank you, Nick. It's enclosed in brackets. Okay, it's enclosed in brackets. When you see a function in Excel and you see the parameters are one or two of the parameters is enclosed in bracket, What does that mean, class? What does being enclosed in brackets in an Excel formula mean? Anyone? Anyone, class? Maybe you have, of course, you have worked with formulas before, functions in Excel before, but maybe you have not paid attention so much to the enclosed, to the square brackets there. Okay. Yes, Alessandra?
Sir, I'm not really sure, but does it mean that it's from a different file or like from a different sheet?
Okay. All right. Thank you. Thank you for that answer, Alessandra. The answer is the ones in brackets mean that they're optional. Okay. Optional means you may or may not put a value there. It depends on what you're solving. Okay, so the PV there and the type there are optional, which means that you can. It's possible that you're not going to put any values there for as long as you put here that values for the three, the rate, the NPER, and the PMT. Okay, so that's what that means. The brackets there means that value is optional. In our case, okay, let me illustrate that now. In our case, PV is not optional, okay? Because that's what we're solving for is a future value given the present value, okay? All right, so let's start. Rate is this one, right? That's B11, comma, N per stands for number of periods, okay? Number of periods. So we know that our number of periods is 20 there, okay? Comma, PMT, on the other hand, stands for payment. Okay, payment has something to do with annuity. Okay, so let me illustrate that. Okay, so I'm going to draw again. Okay, so this is your timeline. Okay, so depending on your cash flow, one. Let me just shorten the example. Two, three. I'll have to find my digital pen because it's so difficult to write via mouse. Okay, when I say payment, one, two, three, four, five, for example, and all of these are constant. Okay, let's say these are all 100 payments for 5 years. 100, 100, 100, 100, 100. So that's what is meant by PMT there. It's do you recall what the name for this type of cash flow is, or this type of cash flow or payment? What's the name for that class? Starts with the letter A. Anyone? So here 100, 100, 100, 100, 100. It's called your amortization. When you answer, class, please answer to me. Please answer now to everybody. Okay. So the answer is, thank you, Aliana. It's annuity. Okay. So this is an annuity. Okay. Justin said amortization. Yes, also amortization in a different when you're the one paying. Okay. When you're the one paying. When you're the one investing, it's oftentimes called the annuity. Okay, so amortization, same thing. You're paying the same amount. Okay, for example, for a loan or purchase of an item, and then you pay regularly, either monthly, quarterly, etc. Okay, so in Excel, this is PMT. Okay, so going back here to our formula, so this is equal to FV. And then our rate is 12%, comma, NPER is 20 here, comma, PMT. Do we have a PMT here, class? Yes or no, please, chat. Do we have an annuity? Is that an annuity or amortization for that matter? Are we okay? No, you're correct. No. Okay, it's just a lump sum amount, one amount only. Okay, so what do we do? What do we do with PMT here? Okay, you can either type zero, okay, because there's no PMT, or just leave it blank and then comma. So you have two commas. Okay, how will Excel read this? Excel will read the space between the commas as zero because there's nothing there. Okay, so take note of that, class. Now PV. So we will have to put PV, class. There's no PMT. There has to be a cash flow. Okay, and we're going to use PV because that's this transaction. So we initially invest 1 million there. Okay, and then another comma, type. So you have two types here: end of the period or beginning of the period. Now this is needed if it's an annuity payment, class. If it's payment, all right. So since this is not an annuity, it's irrelevant to us. So we can just ignore the type, okay, and close this one. So in this case, we didn't put anything in the type because anyway, this is not an annuity. All right. Then tell me, class, if you got the same answer as the, oops, sorry. If you have the same answer as the, in the chat box, please, again to everyone, yes or no, please. Do you have the same answer as the manual Excel manual formula that we used? Okay. Okay, kay Nix, no, pero si Aliana, yes, yes, okay. All right, you're correct. The absolute value is the same. Okay, absolute value is the same. Control Enter. There. Okay, exactly the same, only that the the FB function gives us a negative answer. Now, why is that so? Okay, why is that so? To to explain that, this is very important. You have to remember this. Okay, why is it giving us a negative answer? It's giving us a negative answer because our present value is positive. So this is 1M, right? 1M, and it's positive. So 1M positive means money went to you, right? You got money. Okay. So after 20 years, what do? Pay back, right? Because this is more like a loan, right? And after 20 years, you have to pay the loan that you took in today. So Excel is very particular about the direction of the cash flow. Okay, what do I mean by the direction of the cash flow? Okay, let's make this, Control Enter. Suppose I make this negative. Okay, negative 1 million means you're putting out money. Okay, outflow. So this is from the perspective of the investor. Negative 1 million, I put out money. Okay, so if the present value is negative, what will be the future value? It will be positive, right? It will be positive here because that means that after 20 years, I'm going to get money. Okay. Uh, let me put this back. All right. Is that clear, class? Kindly chat, please. Do you understand why we're getting a negative answer here? Okay, good. Good. So pay particular attention to that. Excel is very particular about the direction of the cash flow. All right. Now, in this case, we're not interested in whether this situation is a loan or an investment. We just want to know how much is 1 million 20 years from now if the rate is 12%. So I'll just put a negative sign here, class. Okay, negative sign. to convert the negative into a positive. Okay. We're not talking about whether you're loaning 1 million or you're investing 1 million. Okay. What we're talking about is how much is the equivalent value of 1 million after 20 years. And the equivalent value is 9.6, around 9.6 million. Okay. Is that clear, class? I'm sorry, I have to ask feedback from you now every now and then. And I appreciate your feedback. Okay, good. Good. All right. Good. Thank you. Okay, thank you. So uh, again, why did we put a negative there? Why did we put a negative here? Because we're not interested in, we're not really stating whether this is a loan or an investment. From the looks of it, face value, the present value is positive, which means cash came in. Okay, so this is technically just like a loan. You know, money came to us positive. Okay, so the future value will be negative. Okay, because you have to pay back that 1 million. All right. So what's important here also is that the equivalence. Okay. So 1 million today is equivalent to 9.6 million. Let me just uh, round it off. 9.6 million. Okay. 20 years from now at a rate of 12%. Okay. So the question is, which do you prefer? 1 million today or 9.6 million after 20 years? Assuming the prevailing interest rate is 12%. The answer is, class, you are indifferent. Okay? It doesn't matter what you choose. Assuming all things are equal, okay? Of course, there may be certain factors that can come into play, but assuming that all things are constant, so 1 million today is the same as 9.6 million after 20 years, assuming a rate of 12%. So we are indifferent to whatever the option will be. 1 million or 9.6 after 20 years at 12%. Doesn't matter. It's the same. It's equivalent. Okay? So these are equivalent amounts, equivalent values. Okay, once again, I'd like to ask if that question of if that concept of equivalence is is clear, class. Okay, good. Good. Okay. Yes. Thank you. I guess for in this subject, you'll have to type yes or no many times. Sorry about that. Okay, so let's continue now. Okay, now uh, so a little practice class. Use the FB function. What if the number of years is not 20, but 30 or 40? Okay, what will be the future value? I'll give you a few seconds to do that. And please, okay, I'll just get water, class. Okay, I know what you got. Okay, so 30 years, 29 million, 40 years, 93 million. Okay, all right, good, good. So actually, we can just copy the formula here, right? Okay, yeah. I think all of you got it right. Let me see if we can copy the formula here. Control C, Control V, Control V. Okay, I just copied the formula because our formula here, okay, all the givens are also on the same side here. So negative FV, 11 rate, N per PV. So you're correct. 29 and 93. So you notice something very very, let's say, a very powerful illustration here is that you increased by 10 years, the money did not become uh, did not become double. It did become around 20 because this is almost 10. Okay, and then you increase another 10 years, it did not double, but rather it it became x fold. No? So you can see the power of compounding. Okay, you can see that there's a big increase in the amount if you just add some years. Okay, so I'd like us to to answer this question. If you have the same amount, 1 million, at a rate of 12%, okay, how much, how much, how long, okay, how long will it take you? How long will it take for money to double? Okay, so think about that. Okay, I'll give you a few seconds or 1 minute to answer that. Okay, how will you answer this class? How long will it take the money to double? If you have 1 million today, and then the rate is 12%. Okay. Oh, no answer yet? Mhm. Any guess, class? Okay, so let's do this together. Okay. Uh, Here I said that let's make use of the tools, one of the tools in Excel, which is what if. I'm not sure if data, okay, Excel has changed over the years. Okay, data, okay, and let's see, like that. Oh, wait, class, I editing, since it add-ins. Focus sensitivity to. I'm sorry about this. The layout, the tabs has changed over the years. I wait. I can't find the mhm. Before it was it used to be in data. Here it is. Okay. So data, I'm sure it was in data, but I could not find the data tools. Let's see. What's this? Flash fill, data tools, not this one. Ah, sorry. Here. Okay. Should be what if analysis. All right. Okay, so go to data class and then who among you have used what if analysis? There are three functions here, scenario manager, goal seek, and data table. Could you please chat in the chat box if you have used the what if analysis function before? Data, and then what if analysis. Okay, good, good. Okay, good. I'm saying good, class, not because you haven't tried it, but because on the positive side, it's an opportunity to learn a new skill for us. Okay, good. So we're going to make use of data and then what if analysis. In particular, we're going to use this goal seek. Okay, so click this, please. Click this. And this dialog box appears. Now, there are three things that that's important here. First is set cell to value by changing cell. Okay, so there are three parameters here that's needed. And notice the two have arrows here. Before it was a spreadsheet icon. Okay. They changed the icon. How about in your case, class? What appears here? Is it a spreadsheet icon or is it this arrow? Could you kindly tell me? A lot of things have changed. Yeah, spreadsheet, no? Yeah, spreadsheet icon. Okay. I got this I'm using Excel 365. So I don't know what version of Excel you're using. Okay, but it's it's the same. It's spreadsheet icon. In my case, it's an arrow. Okay, so what does this mean? Those that have spreadsheet icons or this arrow symbol means that you have to link. You have to link this cell, this this to a cell in Excel. This one you have to write. Okay, you have to write it. Okay, this one we have to link, and then this one we have to write. Okay, so how do we apply it? How do we apply it here, class? Okay, so set cell, okay, set cell to what value, class? What is it that we're interested in? We want, okay, what is it, class, that we're interested in, class? What is it that we're interested in? Yeah, double 1 million, right? Time it takes the money to double. Okay, how long? Okay, so we're going to, in the same manner, class, this one, we're going to use this as as the cell by which R will Excel will compute. Okay, so let's first okay, let's first once again write it here. Okay, so we want the future value, right? I put a negative here, negative FB. The rate is 12%, comma. The NPER is this one. I'm leaving it blank first. PV is this one. Okay. So if you have this formula, class, it's 1 million because the number of years is 0. If I change this to 10, then this will be the same one here. What happened? Ah, yeah, 10 years. If I make this 20, then it will be the same as this value. If I make this 30, it will be this value, right? Okay, so what we're going to do is we want to make this double 1 million by changing this number of years. So that's the logic behind that. Okay, I want this cell to become 2 million by changing this cell. What we're changing is the number of years. Okay, what we want is this one to become 2 million, right? So let's once again go there. What if analysis? Okay, goal seek. All right. Here, what do we want to set? We want to set, okay, let me go here. We want to set this cell, right? This cell should become what? And once again, you have to write the amount here. 2, 1, 2, 3, 1, 2, 3. There. We want to set this cell to become 2 million by changing what class? By changing this one. Okay. Notice that this is a formula and it's connected to 1 million, etc., etc. Okay. So what will happen is that based on the formula, okay, we want this one to become 2 million. It's double 1 million, and we change the number of years, okay, by changing the number of years. All right. So if we run this, okay, you now can see that this became 2 million, okay. From the present value of 1 million, the future value is 2 million. It will take us around 6.1 years. Okay, so let me redo that. Okay, what if analysis? Goal seek. Okay, once again, set cell. What are we going to set? The goal is to make this 2 million, right? 1, 1, 2, 3, 1, 2, 3. By changing what cell? This cell. Okay, Control Shift Enter. You see, Control Alt. Control Alt Delete. Oh, sorry. Oh no, cancel. No, Control Shift Enter. Control. Control. Wala. Okay, sorry. Okay, again, set cell. Set cell is this one to 2 million. 1, 2, 3, 1, 2, 3 by changing this cell. Okay. Control C. Okay. Control V. What's the command for? Okay, anyway. All right, one last time. So this one, set cell, this one, to what value? 2 million. 1, 1, 2, 3, 1, 2, 3, by changing what cell? This cell. Control Alt, is it Control Alt print screen? Yeah, I think so. Control Alt print screen, Control Alt print screen. Okay, and then Control V. There you go. Okay, I just wanted to copy the goal seek here so that you are guided. Okay, if you want to review this later on. So what did I press? Control Alt print screen. Okay, let me repeat that. Control Alt print screen. I'm not sure with Mac. I think it's Control Option print screen. What I wanted to do was to preserve this so that next time you review what was done here, you know what was the parameters that were used. Okay, so let me repeat the process class. What if analysis? Goal seek. Okay, set cell answers what value do you want. Okay, what cell are you changing? I'm changing this cell. I want this cell to become 2 million. So that's the question that you need to answer. Okay, and what are you going to change? We're solving for the number of years, this one. Okay, and before you press OK, Control Alt print screen for those of you who are Windows users. For the Mac users, it's Control Option print screen, I think. Would you kindly confirm, class? Control Alt print screen for Windows users, Control Option print screen for Mac users. I'm using Windows Control Alt print screen. There. And then if I press OK here, OK, and Control V. There. All right. So, okay, let me pause for a while, class. And may I have your feedback, class, if you got it? Do you have any questions, clarifications? Good. Okay, good. Good. So, even if this is the first time you're using GoalSeek, there are lots of things that you can do with GoalSeek. However, make sure that your model is already set. Okay. If you did not put here the FV function, then this would not run. Okay, because this one is linked to these values. So if this was blank class, then this would not run because uh, there's no link to your present value, to your time, to your period, and to your rate. Okay, you should set up your model first and then do your goal seek. Okay, all right. So moving on, class. How about present value? So this is similar to your future value. The only difference is that here, present value, on the other hand, is equal to future value times 1 plus r raised to the negative t. And that can easily be proven or shown. So let me annotate. So you have your future value is equal to present value times your compound rate, 1 plus r raised to the period. So to get your present value, okay, you just have to transpose this. So this becomes PV is equal to FV, okay, divided by your 1 plus r raised to the t. Okay? Or it can be written as FV times 1 plus r raised to the negative t. That's why you have a negative here. Okay, and the process of getting the present value given your future value is called discounting. Okay, compounding to get the future value, discounting to get the present value. Okay, and this factor 1 plus r raised to the negative t is called your discount factor. Okay, it's called your discount factor. All right, so let's go to the present value process. Okay, present value here. This time, we're going to link it with this one. Given the future value at 9.6, 20 years, 12%, of course, we know that we should be getting 1,000, 1 million, okay, because these are just equivalent processes. So using the formula, let's do this together. So this is equal to, the future value is this one, multiply that by the 1 plus the rate is 12%, okay? Shift 6, negative, okay? Negative period, okay? There, class. Okay, the formula, class, is future value times 1 plus r raised to the negative t. Okay, control enter. Okay, and then you get 1 million, of course. Okay. Let me remove the dollar sign. Okay, so it's 1 million. Okay, as expected, class. As expected. And let's use the PV function. PV function. Okay, so the PV function returns the present value of an investment, the total amount that a series of future payments is worth now. So how much is 9.6 million after 20 years, which was obtained in 20 years time at 12%? How much is that now? So once again, we can use the PV function. The rate is 12%, comma, and per is 20 years, comma, There's no PMT here. This is not an annuity, comma. The future value is 9.6 million. The type ignore because this is not an annuity. Okay. And we expect to get negative 1 million. Okay. As I said, Excel is very particular about the direction of the cash flow. So if your future value is 9.6, that means it's an inflow. Therefore, the present value should be an outflow. So to remove that negative there, let's just put a negative here before the PV. And then control enter. There, 1 million. Okay. Any questions, class? I hope you got it. It's just a repeat of the future value process, only that we're getting the present value. Okay, please chat in the chat box if you got both the formula and the function. Okay, good, good. Jashan, did you get it? Okay, wala pa yata si Jashan. Okay, thank you. All right, so okay, so I hope the computation of future value, present value for a single lump sum is quite easy using the function of Excel, FV, and PV. Or of course, you can use the formula itself. No problem. You'll get the same answer. Okay, now we go to another type of cash flow. For the above, we just used single lump sum. Now we go to an annuity. Okay. So for annuity, you have two types. Okay, we have annuity ordinary. Annuity ordinary, let me remove this. Okay. Annuity ordinary begins at the end of the period. So this is the beginning. And then at the end of this period now, you have this one, 2000, 2000, 2000, 2000, 5 years. On the other hand, annuity due begins at the beginning of the period. Here, 2000, 2000, 2000. Okay, so both of them have five cash stream flows of 2000. The only difference is that annuity ordinary begins at the end of the period, while annuity due begins at the start of the period. Okay? Now, let me ask you one thing. Which do you think will give you a higher present value? Is it annuity ordinary or annuity due? What will give us the higher, assuming that you have the same cash flow? Okay. The same rate. Okay. Which type of annuity will give you a higher present value? Ordinary. Okay, thank you, Nix. Ju, Jashan, thank you. Please send your answer to me, please. Ju. Okay, the answer is Ju. No? Why? Why is it Ju? Because take a look at the cash flow of Ju. You have outright 2000. So the present value of 2000 is already 2000. Okay. So as regards the present value, you notice that this one, annuity ordinary, is the same as this one. So no question about these cash flows. They will be the same. The present value will be the same. The only difference is that for an annuity ordinary, we have 2000 after year 5. Okay. For Jew, you have 2000 now. Okay. So which has a greater, since these are all equal, no problem with this. Okay. Same present values. Of course, the annuity Jew, which has 2000 now, its present value is 2000. while the present value of this one will be lower than 2,000. Therefore, annuity due, of course, gives us the higher present value. Okay. All right. Which will give us the higher future value. Please give your answer to everyone. Share your answer to everyone. Annuity ordinary will give us the higher present value. So which will give us the higher future value? Ordinary, okay. Ordinary, okay. Good, okay, good. All right. So, what will give us the higher future value is, of course, annuity due. Okay, so I got you there, class. You know why? Okay, if a cash flow has the higher present value, then of course it will have the higher future value, right? Obviously, di ba? Okay. Okay, if you convert this into a present value, let's say the conversion is 1.5. Okay, let's have by I we can get the present value of this class, but let's just assume that it's 3,000. And we said a while ago that this will have a higher present value, right? Let's say the present value is 3.2. Okay. Okay, and again percentage. Okay. Let's say the present value of annuity ordinary is 3,000. Okay, the present value of annuity due is 3,200. Okay, we said that the annuity due will have a higher present value, right? So if it has a higher present value, then it should have a higher future value, of course, because the future value is dependent on the present value, right? Does that make sense, class? Take a look at the formula for future value. The future value is equal to the present value times your compound rate. Okay, assuming that the compound rate is the same for both. So the higher present value will, of course, give you the higher future value. Okay, so I hope that's clear, class. Could you please chat if that concept is clear? So the annuity due will give us the higher present value, the higher future value. For what reason, class? Because it has the higher present value. All right, good. Thank you. Okay, how about the others? Is that clear, class? Okay. All right, thank you. Thank you. Appreciate your feedback, class. In case you have questions, please don't be shy to ask a question. Okay. So now we take a look at annuities. Okay. Annuities. As we said, so let's take a look at this one. Here, let us mathematically show the present value of an annuity of 30,000 for 30 years and differentiate it with annuity due and annuity here, annuity ordinary. All right, so 30,000, this is annuity ordinary, right? 30,000 for, we'll copy this, 30 years. 30 years of 30,000 there. Maybe let's format it a bit. Separator, but no decimal place. All right. On the other hand, our annuity due is 30,000. Okay, let me format it also. Control 1, number, use separator, and then no decimal places. All right. So this is the difference between your annuity due, annuity ordinary. It starts at the end of the period. So this is the beginning period. At the end of that is period 1. So 30,000. 30 years. Annuity due immediately begins at 30,000. All right, so let's compare the present value of each of these. Okay, so to compute for the present value, okay, we can let's use the formula class. Okay, let's what are the rates? Let's put this here. Control C. Control V. Okay. Number of payments is 30. Interest rate is 10%. Okay. So how do you compute for the present value of an ordinary annuity? The long cut is to get the present values of all of this. What's the present value of this? What's the present value of this? Present value of this, present value of this, present value of this. Okay? Once we get the present values of all of these cash flows, then we can add them. Okay? We can add them already. We cannot add 30,000, which occurs after 1 year, to 30,000, which occurs after 2 years. We cannot do that because it will violate the time value of money. Okay? Money has cost. So you cannot add cash flows that belong to different time frames. Okay, so let's take a look at, let's compute this class using the formula. So to get the present value of this one, which is after 1 year, okay, it's equal to your future value times 1 plus your rate, okay, this one, okay. So we can fix this. You know how to fix sales class? How do I fix S11? Anyone? How do I fix S11 so that I can just copy that to the right? Are you familiar with fixing absolute and relative cell references? Yes, correct. F4. Thank you, Nix. F4. So let me discuss that first because that's very important. Okay. When we talk of cell addresses class, okay, for example, this one S11. S11. Okay, there are what we call absolute and relative cell references. So S11, column S, and row 11, right? That's what this means. S is the column and row 11 is the row. Okay, in this case, S11, column S is relative and row 11 is relative. Okay, so this is both columns and rows are relative cell references. When we say relative class, it means that it can change. On the other hand, if I make it $S11, okay, in this case, S becomes absolute, 11 is still relative. Or if I make it $11, okay, whichever position has the dollar affixed to it becomes absolute. This is now absolute, row 11. This is now relative, okay? And if you have $S, $11, okay? This is both absolute S, absolute column position, and absolute row position. So what do we mean by relative and absolute?